Chances are you've been told repeatedly to put your phone in a Faraday bag when attending a protest to protect your device from being tracked and information from being extracted. Faraday bags are a more accessible way to have a portable version of a Faraday cage. The metal construction of a Faraday cage can deflect external electric charges and scatter them across its surface. This then creates an electromagnetic shield to counter the radiation or electric charges, positive and negative fields counteracting each other. Microwaves and elevators are an example of how Faraday cages function. They're essentially metal boxes. Microwaves try to keep the waves inside while heating up your food, and in elevators you might have noticed that it's difficult sometimes to get phone reception depending on your carrier. The metal boxes of microwaves and elevators help to ward off the ingress and egress of specific electromagnetic waves. The problem is that everyday Faraday bags don't carry over well from Faraday cages, and not all Faraday bags are created equal. Many consumer-grade Faraday bags are poorly made and can create a false sense of security. So for the everyday carrier, don't consider them foolproof or airtight. Most Faraday bags are designed to ward off Wi-Fi, Bluetooth, RFID, cell signals, and EMPs in a specific frequency range. None of them are designed to block every single frequency, and many Faraday bags block some but not other frequencies. For instance, some Faraday bags block cell signals but not GPS, Wi-Fi, or Bluetooth. For their construction, Faraday bags typically start with an inside layer of woven fabric metal or mesh made out of materials like nickel, copper, or aluminum. Then there's often another layer like mylar or a metal-coated polyester material that's similar. And finally, there's a protective outer shell, often made of nylon or plastic materials for durability, topped off with Velcro, resealable strips, or magnets for closure. Now, most people, when using Faraday bags for their devices, use them incorrectly, impatiently, or in ways that render them ineffective. Additionally, people often forget to protect all of the other devices outside of your phone that emit signals, such as wireless earbuds and headphones, smart glasses, key fobs, AirTags, smart watches, smart rings, smart wearables, anything that communicates with wireless-enabled frequencies. Imagine you're underwater carrying a waterproof bag with your phone in it. If you open up the bag while underwater, water will get in, even if you open the bag one time for 1 second. That is all it takes to gain access to your device. The water here represents malicious entities like agents of the state that are trying to get access to your information and devices through equipment like stingrays, aka ISMI catchers, to spoof cellular towers and take your information, or geofencing to broadly capture swaths of devices that are at a specific location at a specific time. If you decide to use a Faraday bag, your phone should be off and sealed inside of the bag the entire duration of time you are trying to protect yourself. Most people, however, use their Faraday bags like a regular bag. They'll have their device inside of the Faraday bag but turned on, and then they open it up periodically to check it. But remember, opening it up even one time is enough to compromise the entire setup. It's additionally important to understand the metal mesh and material that is often used to line those Faraday bags. When you open and close, or you fold or crease this material repeatedly, it can wear out the surface and create gaps for more waves to pass through. And this means that your Faraday bag is no longer a Faraday bag, but just a regular bag. An example of this material compromise can be seen in many of the cables and cords all around us every day. You may have come across a worn or broken charging cable to get a glimpse of what's inside. Inside of the external jacket of the cord itself, usually made with PVC, there's often a foil wrap or braided metal around the wires themselves inside. In good cables, that shielding serves a similar purpose to Faraday cages. The metal jacket keeps the signals inside the cabling so it doesn't interfere with other signals and vice versa. But these cable housings can easily wear out and break down, compromising the cable's performance and protection. This is why, by the way, it's not ideal to fold cables tightly because it can damage the shielding inside. Instead, it's recommended that you loop them loosely. But again, we as humans that jam everything into our bags and pockets often cannot or do not consider these factors. A Faraday bag's closure mechanism, whether a resealable slider, Velcro, magnet, or something else, can also be a point of weakness. It's easy to not press down all the way on a slider, or to accidentally not seal Velcro folds fully, and these often wear out or accumulate particles which make them less effective. And of course, there's always a matter of common human error. If you don't close it completely or open it even once, that is enough to have your data swept up. We, the humans, often are the ones that cause more exploitable vulnerabilities in these scenarios. It's like inviting a random person into your closed secret signal group, or using Proton but writing "top secret, meet at the corner at noon" in the subject line. The technology can be wonderful and powerful, but there are so many factors to holding privacy and security together that need to happen. So there are all of those factors: quality, variation in manufacturing, differences in frequencies that they might keep out that you have to test for, closing mechanisms, material, wear and tear, and of course, human error. There are so many, too many elements there that could go wrong, that could have a flaw, that could create a vulnerability that could be exploited. Everything needs to be completely perfect for a Faraday bag to work well. And even then, there can be flaws. Humans, we are not perfect, and we shouldn't try to be, and we should understand that when we use technology and use protection. So, if you do decide to use a Faraday bag, remember that they are not perfect. They can dampen some of the amounts of discovery, but they can also seep out information relatively easily. Dampen and seep. This is why if you truly want to remain undetected by your device, it's recommended that you don't carry your device at all. As always, more tips to come. Stay secure and private out there, y'all.